All right, so now let's look at some new limit laws here. So here we have the sum law for limits, and basically the sum and difference law for limits are pretty much similar, are very similar. So here we see if we have the limit of a sum, okay, that's equal to the sum of the limits, right? So in other words, I can break this up and say, okay, well, I can either add these two functions and take the limit, or I can take the limit of these two functions individually, right, and then add them together after. All right, and that's the same with the difference as well. So the limit of a difference is equal to the difference of those limits. Okay, the let me say a little more and then add a little bit to that. So the limit of the difference of two functions is equal to the difference of the limit of those two functions individually. Okay, and so if the limit of f of x is a or L, excuse me, and the limit as x approaches a of g of x is m, then you can just add L plus m, right? Same thing here. We can just subtract L minus m. All right. Now, if we multiply by a constant, so if I have a constant times a function and I take the limit as x approaches a, then that's equal to the limit of f of x as x approaches a and then the constant on the outside. Okay? So I can basically take the limit of that function and then multiply by the constant outside if I want to. Okay? So the limit of a constant multiplied by a function is equal to the constant multiplied by the limit of that function. Okay? Now next, product law for limits and the quotient law, right? Those are basically the same thing. So if I take the limit of a product of two functions, then that's equal to the product of the limit of those two functions individually, right? So it's that L times m thing, right? L multiplied by m. And the same thing with the quotient. If I have the limit of a quotient of two functions, then that's equal to the quotient of the individual limits of each of those functions. Okay, so it's L divided by m, as long as m is not equal to 0, right? If m is equal to 0, or if this limit is equal to 0, then it would be undefined, right? And then we have to switch it up a little bit, and there's some different techniques that we'll talk about in another lesson. But for right now, if we take the limit of a quotient, that's equal to the quotient of those limits, as long as the denominator limit doesn't equal 0. Okay. All right, and then the power and the root law. And remember that a root is a type of power. We know that an nth root is the same as raising something to the 1 over n power, right? It's a rational exponent. So anyway, the power law says if I take the limit of a function to some power n, then that's equal to the limit of that function to the power of n. Okay, so I can take the limit first and then raise that limit to that power. Okay, so it can be L to the nth power. All right, as long as we have positive integers there. And then the root law for limits is basically the same thing. If I take the limit of the nth root of f of x of a function, then that's the same as if I take the limit of that function and then put it to the nth root. Okay, so it's the nth root of L. And that's as long as n is odd, so as long as we have an odd nth root. And if n is even, then we have to have the function greater than or equal to 0, right? Because we can't have a negative underneath the radicand if the radicand is negative, right? So if you have an even power index and a negative radicand, that'll result in an imaginary number. All right, so those are basically the laws. So we'll be practicing using these laws. If this doesn't all make sense right away, hopefully you'll see this in the examples and you'll see how they work. So, and this is something you don't have to memorize necessarily all these things, but it's kind of good to get a sense of what they are, how they work, how to use them, and and how to be more efficient in finding limits with these laws. So finding ways to use these laws to help you come up with the answer a little more efficiently without having to make a table or even graph or things like that.